Hello, everybody. Welcome back to another episode of Beyond the Blueprints. My name is Chad Jennings, and I'm joined today by Philippe Saadé, who is a AI ML project manager at Wikimedia. And we're going to be talking about a project that he's doing to make the data inside of Wikimedia and Wikidata available to a whole new set of users. So, Philippe, welcome.
Thank you. Yeah, so I'm Philippe. I think everyone's familiar with Wikimedia and Wikipedia. To show just a little bit of difference between Wikimedia Foundation that is hosted in the US and Wikimedia Deutschland. Basically, the foundation hosts and maintains the infrastructure behind Wikimedia projects and Wikipedia, whereas Wikimedia Germany maintains more Wikidata.
Okay, gotcha. So Wikidata, and we're going to get in and define this and the relationship between these various wiki properties. So obviously, as you just described, you maintain Wikidata. How is that related to Wikipedia?
So basically, it's the same type of data. It's around general knowledge data, but Wikidata is a database designed and structured in a way to be searchable by computers, whereas Wikipedia is presented for humans and in the form of searchable and human readable articles.
Okay, so same type of stuff, but aimed at computer readers and computer searchers. This is a big deal. Like to the audience here, Philippe and I did a little bit of research, and we've according to Statista, Wikipedia.org gets about 4 billion monthly visits. Um, and that's not unique monthly the visits, that's just monthly visits. But still, like, there are only 8 billion people on the planet. Like, this is an appreciable, like 4 billion is a lot of hits. Um, so, making that corpus of data available to AI and to generative AI and to grounding models, like, this is a big deal. It's a very valuable asset to humans. So, Philippe, what's special then about Wikidata?
So, Wikidata is a free and open knowledge graph, one of the largest Wikimedia projects, and it has today around 2.4 billion edits in total. It's collaborative and it's multilingual. Um, it has around 120 million pages and it supports around 300 languages. And what I found very special is that it's highly connected to a lot of external resources and external databases. And data is also being used in a lot of for a lot of external projects, providing data that is accessible by both humans and machines.
Okay, so and if correct me if I'm wrong here, but the overall mission is to provide this essentially this data asset, human readable in some use cases, like the Wikipedia, machine readable, as in Wikidata. Like the benefit to the planet is, here's a trusted corpus of data that you can use for whatever your purposes are.
That's exactly right.
Perfect. An excellent thing to have in existence. So let's get into the specifics here. So what's the specific goal and use case that you're solving for here?
So basically, now with the increased popularity of generative AI, we're looking into making Wikidata more accessible to LLMs, who basically make use out of textual data that is more found on Wikipedia and less on knowledge graphs, which is basically Wikidata. Basically, our mission here is, and by making Wikidata more accessible to LLMs, aim to make generative AI more reliable, more transparent, having them make use out of these logical connections that are found on Wikidata, and as well give people and the community control over the data that is referenced by LLMs.
So from what you just said, like one of the main use cases for all of that trusted data would be grounding LLM models and, as you said, getting better accuracy and transparency out of them. That's fantastic stuff. We should definitely do this. Can you talk about some of the specific challenges that you're trying to address here?
Yeah, so basically, before this project, um, Wikidata was the only way to access Wikidata is through SPARQL, which is basically a query language like SQL, but for knowledge graphs for accessing Wikidata. And SPARQL is complex. You need to learn how to write SPARQL to be able to access Wikidata. But on top of that, you need to know how Wikidata is structured in a particular domain to be able to write a proper SPARQL query. So now with the solution with the vector database, we're creating a more simple and accessible way to explore Wikidata before writing your SPARQL query.
I definitely see the value of this, of making this platform suitable for AI use cases. We talked about grounding, better transparency, but let's articulate a few specific reasons why folks would want to do that. So, Philippe, can you give us a couple?
Yeah, so I think what would be interesting to look at is how currently people make use out of Wikidata and why this structure and the knowledge graph is useful for people and like for projects. I think one interesting way is the multilinguality and making applications more supporting multilingual data. So basically, the way Wikidata provides multilingual information is one item on Wikidata is translated into multiple languages. But comparing to Wikipedia, for example, you have completely different articles in different languages and they're not connected to each other. It's not a one-on-one translation. Something like a project that's using this multilinguality, for example, is OpenStreetMap. And basically, they're retrieving the labels from Wikidata of places, locations, monuments in different languages based on the user's request. Other projects that make use out of Wikidata are, for example, search engines. Basically, from one side, they retrieve general knowledge information to provide users with quick information about a certain person or certain place and so on. But another way is basically the way Wikidata is highly connected to a lot of external resources, from museums to books to cultural heritage institutions and so on. So Wikidata in that way can be considered as like a hub linking all these resources together into one.
It's a super valuable mission statement and mission to provide, like particularly in this day and age, right, where the flow of trusted information is just, the flow is accelerating. It's getting faster and faster, and so like having something as foundational that's powering search engines, that's powering OpenStreetMap, as a trusted source is just really, really fantastic. All right, hey Philippe, please walk us through the architecture diagram of your API to Wikidata.
All right. So this is basically the architecture for the API that's providing users access to the vector database. And as we can see here, we have two routes in the API. One is a search route, which basically provides users access to, provides users the ability to do a search on the vector database, and a similarity score route, which in this one, users define particularly which Wikidata items they want to compare their query with and get similarity scores.
Okay, so like the top one is, hey, I'm just looking for something, and the bottom one is, show me all the things that are like this thing over here.
The bottom one is like, I have a sentence. I personally defined Wikidata items. Give me how similar in context these items are to the sentence.
Okay, all right. One is searching for broad stuff. The other one is like, I have a thing, a sentence. Thank you for the correction. And show me the things that are related to that. It's a much more
Yeah,
focus. Okay, that just
yeah,
explains why you've got a bifurcated architecture here. Please continue.
exactly. So yeah, so for the search, first of all, as you can see, we take a query from the user in natural language, and some parameters for configuration. And basically, we're performing a hybrid search, which is combining keyword search with vector search. The keyword search, basically, we're using the keyword search already available on Wikidata. So we directly query Wikidata and get results for that. And for the vector search, we first go provide the query to the embedding model provided by Gina, and then which will then transform our query into a vector, and then construct a query to the vector database that takes into consideration the vector along with the configurations from the user.
When you first presented this to me as we were prepping for this, you said this part blew me away. So I just wanted to point out to everybody watching or reading the blog is that box there with the Wikidata search, right? That's essentially the Wikipedia experience that we've all had. So like all of the Wikipedia structure is focused inside that single box. That's how big a block diagram this whole thing is. It's just really impressive that you've been able to like achieve all of this or build all of this when that single box is actually as big and impactful an element, even to the rest of the world. It's pretty impressive.
Thank you. Yes. Yeah. So once we have our query set up, we can then query our vector database, which is an Astra DB database hosted in the IBM DataStax infrastructure. And as we can see here, our database is split into items from Wikidata and properties of Wikidata. And each of them is also sectioned into different languages because we have vectors per language in the vector database. And then based on the configurations, we decide which section of those we want to query. And after that, we get the results. We combine the keyword search with the results with the vector search results using reciprocal rank fusion, which is basically a very simple way of combining these two lists that takes into consideration which items are higher on the list and which items show up two times in both lists. And then finally, here we have our results. However, we do have an additional step of re-ranking that is basically chosen by the user. And in the re-ranking, we call the Wikidata API to get the latest up-to-date information from Wikidata. And then we use the re-ranker model from Gina. And we order the list based on the highest relevance. We kept this part optional because basically, even though it's providing more accuracy in the results, at the end of the day, it's just reordering the list. And in some cases, for example, if we're looking into a RAG application, that is, in both cases, you're providing the full list to an LLM. The ordering of the list doesn't really matter. So in that case, the user can skip the step and make a faster query.
That's a really nice design element for your API, depending on depending on what kind of user is writing the query.
Yeah, we try to make it accommodates as much use cases as possible.
So this is a lot of stuff. And as we pointed out, like some of the boxes, also, have infrastructure significant enough to handle billions of monthly hits. What infrastructure is this running on, right? Because Wikimedia hosts its own.
Yeah, exactly. So this is running on the Wikimedia cloud services, which is basically an infrastructure hosted by the Wikimedia Foundation.
Okay, and can you talk a little? I mean, that's quite a choice to host your own infrastructure. Can you talk a little bit about why Wikimedia makes that decision?
Wikimedia basically and Wikipedia basically started way before cloud services became a thing. However, we decided to keep that a thing and not like go into cloud services for many reasons. But I think one of the most obvious or most valuable reason for us is that is because of privacy, and we want to make sure we keep the community who are editing and putting this effort on Wikipedia and Wikidata. We want to keep their information private. and mostly because of removing their liability in terms of when they're editing, and we want to instead take the full responsibility ourselves.
So the privacy is quite interesting. But I also imagine that some aspect of Wikimedia's desire to host its own infrastructure is just also like control of where things get stored, control of how things get stored, control of where the compute gets deployed, et cetera. So this way you're just not at all reliant on a cloud provider.
Yeah, that's a big aspect of it. We want to make sure what type of information is stored, particularly information that is part of the users and who can actually as well access these types of information.
We here at IBM, like it's our tech that often gets used when folks have an on-prem requirement, as well as like folks that want to deploy on-prem. Not the case for you, but when they've got a hybrid system where they've got on-prem and cloud as well, we often get called in there. Here, it makes total sense that you've selected some elements from our stack because, like, it's an on-prem requirement.
Yeah, totally. And in that case, this whole project that we're working on is part of accessing the data rather than editing the data. So, and the data, as we all know, and at least Wikidata's data is licensed CC0. So, for that aspect, it makes sense.
Gotcha. Well, this is clearly big work, right? Big in scope. It's complex. There are a lot of boxes on the architecture diagram. Go ahead and tell us a couple challenges that popped up along the way here.
Yeah, so one of the challenges that we saw early on as we're looking into developing this solution is, of course, resources and all the resources and time needed to be able to develop a solution that is um, efficient enough and can handle the large amount of data that is available on Wikidata. And for that, we partnered with IBM DataStax to make this possible. Another challenge that we were facing is looking into a solution that is multilingual and can support and is accessible to a global community. So for that, we partnered with Gina to make use out of their embedding model that supports over 100 languages.
Gotcha. So, yeah, like the scope of accelerating with some of the IBM products that overcame that challenge, and the multilinguality. That makes a ton of sense here. Let's take a bit of a shift now, and instead of talking about the internal stuff like the architecture diagram, etc., let's talk about the impact. Like, what impact did all of that work have for your end users?
There's a lot of impact for the user, for the users. I think one of the most useful ones or the most prominent ones are, for example, 30 times faster performance.
Okay, wow, that's a lot. That's a big.
Yeah, for sure. We saw that compared to our initial experiments that we were trying to do locally. And it's very important for the users who are looking into making use of this vector database and making it part of one component into their RAG application. So speed is a huge factor for them to consider that. And another aspect is, making it possible for us to develop a solution in a short time and creating a prototype for users that we were able to provide and get their feedback on it so that we can improve um, our solution as well. I think another impact that is uh, for the users are 90% reduction in development time that gave us the opportunity uh, to focus more on experimentations, on trying out different results, different solutions, and seeing the results and providing a solution that is more accurate for the users to make use out of. I was gonna also refer to the scalability and the amount of the ability to be able to handle the amount of data that is available on Wikidata with fewer effect on the query time.
Excellent. Yeah, because I mean, if you scale the data and the query time goes down, then you haven't achieved anything. So, yeah, I mean, data is big these days. Anyway, for a company that runs its own infra, like these are pretty awesome ways to. These are pretty awesome accelerants and accomplishments. So, my compliments. What were a couple things that you all learned that surprised you as you were going through this?
Um, I think one of the interesting ways as we're developing the solution, initially we were looking into a solution that is, or what we could do to make this more multilingual. And our initial thought is let's create a vector for each item on Wikidata per language. So a vector per language. And initially I thought, I looked into this idea and I thought like it feels redundant. It feels like it's not going to be very useful because if the are one to one, then what's the point of creating these additional
There's no
vectors?
right, like, there's no actual new information, it's just a different representation of the same in a different language.
Yeah, 100%. And I thought this might even reduce the accuracy because you're adding too much vectors and this might create more noises in the vector database. But as we developed this, as we experimented with the solution, I realized that actually accuracy was improving as we're querying on more languages. So it gave me that realization that the embedding model was not only capturing like a one-on-one translation, but rather also the nuances that are behind each language. So it's kind of creating a more diverse vector database that is improving the results.
That's it's a wonderful and numerical example of how diversity, actually helped in this case. Um, yeah, terrific. Thank you for sharing that one. Let's shift again and look forward a little bit. So obviously you've done a lot of work here. You've launched it relatively recently. I think I saw the blog post, and we'll add the blog post that you guys, launched this API just a few weeks ago. So now that you've got it out, like, what are you looking forward to? Obviously you want to watch the traffic build, but like, what are you looking forward to developing next for everybody?
So in terms of the vector database, we're looking into expanding it more, adding more languages and improving things as we go. We hope that people make use out of the vector database, build projects on top of it, and give us their feedback so we can also look into things that we can improve as well. One interesting project on top of that that we're looking into, we actually developed an MCP for Wikidata, and it's making use out of the vector database. So it's kind of like an interesting way of combining the exploration aspects that the vector database provides, along with like the precision of SPARQL and accessing the knowledge graph. So I'm hoping that we develop this further and get people to test that as well. And yeah, maybe even some new and interesting solutions, maybe something like GraphRAG that could take into consideration the structures of knowledge graphs along with vector search.
Well, in this day and age, there's certainly no shortage of new tech or new things to try. Um, I really hope that this project gains a lot of traction, and that your MCP server, as well as the vector API and the search portion of the API, I hope those get a lot of use because personally, I think this is a exceedingly valuable project to just have in existence. Philippe, thank you very, very, very much for the work that you and your whole organization is doing, and thank you for joining us.
Thank you so much.
Splendid. And we'll go ahead and sign off here. Thanks, everybody, for joining.